అంటే సాల్వ్ చేసే అంశాలను ఎవరికి వాళ్ళు చెప్పాలి. మీ పేరు అడగాల్సి వస్తుంది. Then I can understand how much responsible is it like. So patient 3 days absent. Solved. Option is right. Okay. So I asked more than 4 or 5 times. Is there any doubt? Nobody responded. At least revise this or examples. I told you to revise the pseudo force. Under pseudo force revise there in the car. All of it did. Revised. So I've given different situations, pseudo force magnitude I've given, directions I've given. So we solved normal reaction acting on a block when it is there inside the lift. Okay. You observe from the ground or you observe from the lift. Okay. You observe from anywhere. The normal reaction remains same. That means in the question they don't give the observer. మనం ఎక్కడి నుంచి solve చేయొచ్చు. But మనం solve చేసేటప్పుడు తప్పు చేయకూడదు. Suppose if you are observing from the ground, then no need of any pseudo force. Pseudo force apply చేయాల్సిన అవసరం లేదు. If you are inertial observer, then no need of pseudo force. When you require the pseudo force, when you are a non-inertial observer. If you are a non-inertial observer, then you will require the pseudo force. Okay. Clear? Second situation. So from this, we will go for apparent weight. Apparent weight of object inside the lift. So what is the meaning of weight? So the normal reaction acting on the block, we call it as weight. Normal reaction acting on the block or object. Normal reaction acting on the object. You can write down. Object is called as weight. And don't think that normal reaction always equal to mg. It can be more than mg, it can be less than mg. It all depends on the what other force also acting. Meta force ela act avutune dani meeda kuda depend ayi untadi. Okay. So don't think that normal reaction always equal to mg. No, normal reaction not always. Sorry. Normal reaction not always equal to mg. So normal reaction can be equal to mg, more than, and even less than. Okay. So try to understand these points. Then how to go for apparent weight of an object inside the lift? Suppose there is a lift. Okay. So lift is at rest. One man is standing on the weighing machine. Let us say this is the weighing machine. Then what is the reading shown by the weighing machine? If mass of the man is mg, then mg will act downward, normal reaction will act upward. So what is the rest flow? As lift is at rest, you observe from anywhere. You lift one observe and ground one observe. So both observers will see that man is at rest. So then n value is equal to mg, which is we call it as weight. What is the reading of the? Okay, I'll write down. Okay. What is the reading of weighing machine? Reading of weighing machine is mg. It will show the mg on. Okay. So next scenario. Next scenario is this is the weighing machine. Let us say man is standing on it. Man mass is m. Okay. Now lift is moving with constant velocity upward, or it is coming down with constant velocity. Lift is going up with constant velocity or coming down with constant velocity. The A situation is this question. You can take any situation. Then what is the weight shown by the weighing machine? Weight shown by weighing machine inside the lift is called as apparent weight. True weight and apparent weight. Now true weight will be equal to apparent weight. In these two cases, mg will be the weight because moving with constant velocity, no acceleration is zero. So what are the force acting? The normal reaction acting on the man is N. On the weighing machine, N will be acting. On the man, mg will act. So this is the normal reaction acting on the weighing machine. Whatever the normal reaction will act on the man, same normal reaction will act on the weighing machine also. Action reaction to it. The normal reaction acting on the weighing machine we call it as weight. Weight shown by the weighing machine. Normal reaction acting on the weighing machine we call it as weight of that object shown by the weighing machine. Okay. Then as it is moving with constant velocity, in both the cases, what the acceleration is? In both the cases, acceleration is zero. Then n minus mg is equal to net force 0. Then what the n value is equal to? N value is equal to mg. N value is equal to mg. Okay, na? See, when lift is at rest or lift is moving upward with constant acceleration, so constant velocity, or moving downward with constant velocity. So in both the cases, what is the weight shown by the weighing machine? It will show the true weight. Okay, na? It will show the true weight. N value we are finding, that's it, nothing else. Okay, wrote down now. How wrote down? Okay, go down. Still writing on. Now all of it right now. What is the weight or normal reaction shown when lift is accelerating upward or accelerating downward? Already accelerating upward we solved that. Accelerating downward you have to solve. What is the normal reaction or the reading of the weighing machine? When lift is accelerating upward and lift is accelerating downward. Okay, finish them. So if lift is accelerating upward, so you can write down accelerating upward. This is the weighing machine that is said. It will show the reading. If a man standing, man of mass M standing, then what will be the reading shown by the weighing machine? If you want to identify the reading, you have to go with the normal reaction. Then what are the force acting on man? Mg will act downward, normal reaction will act upward. So to find out the normal reaction, you can observe from anywhere. You can observe from the ground. You can observe from the inside also, inside the lift. మీరు ఎక్కడి నుంచి అబ్జర్వ్ చేయాలంటే మీ ఇష్టం, your choice. If you are observing from the ground, then man will accelerate upward. If you observe from lift, if you are there inside the lift, then man will be seen at rest. Remember, as your observation place changes, motion of the object also changes. So you should be careful in applying the things. Okay, understood? Now I am solving with respect to what observer? The observer is there inside the, he is the observer, O is the observer inside the lift. So as he is there inside the lift, he has to apply the pseudo force. What is the pseudo force? Is MA downward. And the lift is accelerating upward. Opposite acceleration pseudo force to be applied. Mass into acceleration, mass of the object, mass of the man into acceleration of the frame. Then to the observer, how the man will appear? Man will appear at rest. That means N will be equal to mg plus ma. So N is equal to m into g plus a. This is the normal reaction. So then what is the apparent weight? You can say apparent weight or reading of weighing machine. Okay, remember, any question comes of reading of weighing machine reads only normal reaction. Okay, na? So reading of weighing machine is m into g plus a, means it will read more than the actual weight it will read. When lift is accelerating upward, you can say this is the first condition, second condition. Okay, na? This is the third condition. What will be the fourth condition? The fourth condition is when lift is accelerating downward. The lift is accelerating downward. Okay. This is the weighing machine. And this is the man. Man mass is M. Then what is the normal reaction value? Okay. So now find what is apparent weight. Very good, Srjc. So you can take observer anywhere. You can take observer on the ground. You can take the observer inside the lift. Okay, while observer ఇవ్వకపోతే మనం ఎక్కడి నుంచైనా అబ్జర్వ్ చేయొచ్చు. వాళ్ళు పర్టికులర్ గా అబ్జర్వ్ ఇచ్చి అడిగారు అనుకోండి, then we have to answer accordingly. Okay. So now where is observer? I'll take the observer inside the lift. Observer inside the lift. Then what are the original forces acting? The actual forces are mg and normal reaction. Now observer is non-inertial observer or inertial observer? Non-inertial observer. No, he is there in the accelerating or decelerating frame. Then we have to apply the pseudo force. How to apply pseudo force? Opposite acceleration. Now lift is accelerating downward. Then pseudo force will act in upward direction. What is pseudo force magnitude? Mass of the object on which you are applying, means mass of man into acceleration of the frame, means acceleration of lift. Acceleration of frame is nothing but acceleration of lift. Okay, na? Then to this observer, how the man will appear? Man will appear at rest. Man will appear at rest to the person or to the observer inside the lift. So then I can write down N plus MA. Total upward force is equal to downward force. Then N value is equal to mg minus MA. Then what is the N value is equal to? M into G minus A. This is the normal reaction. So here normal reaction is less than weight. Here one important condition is that, note, if lift is freely falling, what is the meaning of lift is freely falling? Means lift wires broken. Lift is falling under gravity. Then what is the acceleration of the lift then? If lift is freely falling, A value is equal to Z. Then what the normal action value will be? 0. Then what is the weight shown by weighing machine? What is the weight showing by weighing machine? Weighing machine is 0. This only we call it as what? Weightlessness. So when we don't feel our weight, we don't feel our weight when we are falling under gravity. Okay, when we are falling under gravity, we don't feel our weight. That only we call it as weightlessness. Okay, I think you experienced in ఏమంటారు జాతర పెద్ద పెద్ద జాతరలు జరుగుతాయి కదా, జాతర జరుగుతుంది, ఫెయిర్స్, అందులో ఇది ఉంటుంది కదా, ఏంటిది, జైంట్ వీల్, some other థింగ్. స్కై డైవింగ్ వరకు అవసరం లేదు మీకు, బికాస్ స్కై డైవింగ్ మనం ఎప్పుడు చేయం కదా లైఫ్ లో, కొంత అవసరం లేదు. నేనేది చేయను, మీరు చేస్తారు లేదు తెలియదు కానీ నేనేది చేయను. సో స్కై డైవింగ్ అవుతుంది, మనం ఎక్స్పీరియన్స్ చేసిన ఎగ్జాంపుల్ చెప్తాను. ఓకేనా, మనం ఆల్రెడీ ఎక్స్పీరియన్స్ చేసిన ఏంటి, లైక్ ఐ డోంట్ నో ఎంతమంది మీరు జైంట్ వీల్ ఎక్కారు తెలియదు కానీ జైంట్ వీల్ ఎక్కేటప్పుడు కిందకి వస్తుంది, పైకి ఎత్తినప్పుడు హ్యాపీగా ఉంటుంది. దెన్ వైల్ ఇట్ ఈస్ కమింగ్ డౌన్, దెన్ యూ ఫీల్ సంథింగ్ డిఫరెంట్ ఎక్స్పీరియన్స్ ఉంటుంది. Why? Because as you are coming down to some acceleration, you will feel some less weight. Okay, na? Understood? Huh? So this is the apparent weight. Apparent weight or weight shown by weighing machine or weighing machine reading. Okay, all of you wrote down, huh? Anybody writing? Okay, finished, huh? What happened? Finished or not writing? Respond somewhere. Respond with something. No? Finished. Finished. Okay. Okay. Finished. Huh? Finished. Finished. Anyone writing? Or shall I move to next part? Now all of you try for decelerating upward and decelerating downward. We have taken accelerating upward and accelerating downward. No? Similarly, fifth case decelerating downward and sixth case decelerating upward. You can take anyway. Reverse also can take. Now you take with deceleration. You try with the deceleration. Deceleration with upward and deceleration downward. Lift is decelerating in upward direction. What is the apparent weight? If lift is accelerating in, sorry, lift is decelerating in downward direction, what is the apparent weight? Okay, so decelerating upward and decelerating downward. The next fifth question, fifth situation. If lift is decelerating in upward direction. Okay, now a man is standing on the weighing machine, decelerating upward direction. See, now acceleration is negative. Acceleration is not positive. Acceleration is negative. This is decelerating direction. Huh? It is decelerating in upward direction. Then what the normal reaction? What are the actual force acting? Where is the observer? You can take observer any place. You can take on the ground. You can take inside the lift. I'm taking inside the lift. Inside the lift is the advantage. If observer is inside the lift, then you will see that man is at rest. You can balance the forces. Okay, no? So then, what are the force acting? Mg will act downward. M is the man mass, and normal action will act upward. Normal action will act upward. Okay. Now, observer is inertial observer or non-inertial observer? Observer is non-inertial observer, not inertial. Then he has to apply the pseudo force. What is the direction of pseudo force? Direction of pseudo force is opposite to acceleration. Direction of pseudo force is what? Opposite to acceleration or in the direction of deceleration. All of you revised yesterday part. Yesterday I wrote down direction of pseudo force. Direction of pseudo force should be opposite to acceleration of the frame of reference or in the direction of deceleration of the frame of reference. Okay, next statement. Okay, in the direction of deceleration or opposite to acceleration. Now I have given deceleration or acceleration. Deceleration, no? It's a deceleration. Means in the direction of deceleration. So MA will act in upward direction. Pseudo force, MA will act in upward direction. Then we can find out normal action value because the man will be at rest. According to observer, man will be at rest. You have to balance the forces. So N plus MA is equal to Mg. So N is equal to Mg minus MA, which is M into G minus A. So N is equal to M into G minus A. That is the what? Apparent weight or reading of weighing machine. Okay. So this is the fifth case. What is the sixth cases? If lift is decelerating. If lift is decelerating in downward direction. The lift is decelerating in downward direction. Then what is the apparent weight or normal reaction acting, or you can say reading of weighing machine? Now deceleration is downward. So I'm writing negative. Negative stands for what? Deceleration. Huh? Okay. Correct. In this case, normal action will get M into G plus A. Yes, n value will be m into g plus a. Solution is very good. The previous option kind of follow up now class. Very good, nice. See, if you understand the logic, with the logic also you can solve the questions. The physics is something like that. But if you understand the concept, that will be more better. Okay, so what are the forces acting? Mg will be acting downward, normal action will be acting upward. So these are the common forces or real forces. Now we have to verify in what direction we have to take the pseudo force. Why? Because we are taking the observer inside the lift. If you are solving from the ground, there is no issue. If observer is inertial, no need to apply the pseudo force. If observer is non-inertial, then we have to apply the pseudo force. Try to understand that logic. So observer is there inside the lift. If I take the observer inside the lift, then he has to apply the pseudo force. How the pseudo force will act? In the direction of deceleration, means downward. Value will be m into a. So to the observer, the man will appear at rest. All right. So then n value is equal to mg plus ma. See, everywhere we are balancing the forces. Why? Because we have taken the observer inside the lift. With respect to observer, inside the lift, the person will be seen at rest. That's why all forces are balancing outside. Okay, no? And the follow up, Nara. If you revise yesterday part, then it's easy to follow it. Even the surprising thing is, variation is option for 3 days, but still she is able to follow it. That means if you are logically present, understood? If you are logically present, I think you observed my words. I'm not saying you are present or absent. I'm saying that you have to present logically with your brain. Then you can understand. So the normal reaction value is m into g plus a, which is apparent weight or what is it that reading of weighing machine. Okay. So I think we got all situations of lift. Okay. So now you should not do mistake related to apparent weight. Still, if you do mistake in apparent weight, then nobody can save you. But the only thing is, in the questions you may get numbers. So carefully deal them. Okay. Now given G and A, but in the questions you may get numbers. So you have to be careful with that. Okay, Rodana, anybody writing? Then we'll see that some other situations related to pseudo force, non-inertial frame of reference. Okay, Varshita completed. What about others? Okay, so what about others? Nazia also completed. Okay. Anyone writing? Okay, finished done. So the next thing is next example. Example for you can say pseudo force. So what is the next example is? Suppose that there is a one vehicle trolley you can say. Usually people call it as trolley. Now trolley is at rest. Trolley is at rest. Now simple pendulum is hanging vertically. Do you know simple pendulum means? There will be a string. To the string we are connecting one spherical object. Spherical, you can say ball. Ball is connected to the string. If a ball is connected to the string and string is connected to the roof, that arrangement we call it a simple pendulum. Okay. So if you drag accidentally, it will oscillate. Pull then it will have what they say that it will oscillate. It will move forward and backward. I think all of you know that oscillation. Okay. So when trolley is at rest, then pendulum will be vertical. But same trolley accelerate forward. If same trolley is accelerating forward, Then pendulum will make some angle theta with the vertical and it will go in backward direction. Okay, no? Pendulum will make some angle theta with the vertical in equilibrium. Pendulum makes an angle theta with the vertical in equilibrium position. Okay. Now what is the theta value? Can you try? You can take mass of the pendulum is m. M is the mass of the pendulum. Can you try for what is the theta value? How much angle it will make with the vertical in equilibrium when trolley is accelerating forward? It's an acceleration. It's an accelerating trolley. Okay. So here I have not given any observer. So where to take the observer is your choice. From where you want to observe the things. So you can solve from anywhere. You can solve from the ground frame, you can solve from the trolley also. మీరు అబ్జర్వర్ ని గ్రౌండ్ ఫ్రేమ్ నుంచి అని చూడొచ్చు లేదంటే ట్రాలీ నుంచి అని చూడొచ్చు. You can do it anyway. But as the observer changes, motion of the pendulum changes. Anyone getting the answer? tan inverse Chandra to A by G na M also there. M should cancel out, no? M should cancel out. M will cancel out, you will get A by G. Chandra to correct. Perfect answer. Okay, no? So as the trolley is accelerating forward, let us say this is the trolley. As the trolley is accelerating forward, then pendulum will go back. Tell you why it is going back. Okay, we'll make an angle theta with the equilibrium. Now I take the observer inside the trolley. Observer inside the trolley. Okay. If observer is inside the trolley, how will you see the things? So observer will see that. Pendulum is at rest. మనం ఎక్కడ చూస్ చేసుకోవచ్చు కదా observer ground frame లో కూడా చూస్ చేయొచ్చు. So if I take the observer inside the trolley, then pendulum will be seen at rest. Then what are the force acting on the pendulum? On the pendulum, what are the force acting? Mg will act downward. True force. Tension will act along the string. That is also true force. So we have to apply one more force. Without application of that force, we cannot go for Newton's laws of motion. Or at rest, net force 0 we cannot apply because observer is there inside the what? Inside the trolley. Then he has to apply the pseudo force. What is pseudo force direction? Opposite to acceleration, and value is how much? M into A. So because of this pseudo force, the pendulum will go in backward direction. Because of this pseudo force, I can say that pendulum will go in backward direction. Okay. Then how many forces are acting? 3 forces are acting. Is at rest, or pendulum is at rest, and I want to find out theta value. For that, I extend this line. This angle will be theta. Am I right? String is making angle theta with the vertical. Then what are the components I can take? I can take the components of t. So t, I can write down t cos theta one component. What the other component is? T sin theta. So on the pendulum, what are the force acting? T sin theta is acting forward, and MA is acting backward, MG is acting downward, and T cos theta is acting upward. And pendulum is at rest. Means pendulum is in equilibrium. Then what we can write down? All forces should cancel out. Rightward force is equal to leftward force. Okay. Then upward force is equal to downward force. Okay. Rightward will be equal to leftward, and upward is equal to downward. Then if I divide, because we want to find out theta value, not tension, just go with division of two equations. Then it is T sin theta by T cos theta is equal to MA by MG. Then T will cancel out. Sin theta by cos theta is equal to, I can write down, tan theta A by G. Theta is equal to tan inverse A by G. Okay, that is the angle made by the string with the vertical. The same thing you can try from the ground frame also. But if you see from the ground frame, trolley is accelerating, so pendulum also will accelerate because pendulum is there inside the trolley. That's all. Okay. So like this, you can find out the angles made in accelerating frame. See, this all depends on where you want to take the observer. It all depends on the observer also. Okay, you can find out tension value also. For the same case, you can find out tension value also. How to find out the tension? For tension acting in the string. For tension acting in the string, what we have to do? We just square and add the equations. Equation square just adds this one function. Theta value will come because sin square theta plus cos square theta is control. First and second equation when it means square just add here. Then t square sin square theta plus t square cos square theta is equal to m square a square plus m square g square. Squaring and adding of equations. So what is the advantage we'll get? T square if I take common, it is sin square theta plus cos square theta, which is m square if I take common, it is a square plus g square. M square multiplication on a square plus g square, then t square sin square theta plus cos square theta is 1. So t square is equal to m square into g square plus a square. Okay, then t value is under root, so m into under root g square plus a square. T value is right. So this is the tension acting in the string. So not only angle, they can sometimes they can ask you what is the tension acting in the string also, right? Okay, wrote down. Anyone writing? If anyone writing, let me know. I'll wait. Otherwise, we'll go for next situation. Since Kanishka wrote down, Ramesh wrote down, Chandana wrote down, Gauri wrote down, Salil also wrote down, Adil also wrote down. Who is writing? Nobody is writing. Pritam wrote down or writing? Wrote down. Okay. Still I can see so many videos are off. Okay. So let us go with the next case. Next example. So the next example is, suppose on the inclined plane, already we discussed. Okay, na? Inclined plane is fixed. Means inclined plane does not move. Huh? Now if I release the object of mass m, then what happens? Already we discussed this part. What happens if I release the object of mass n? All are smooth surfaces. All surfaces are smooth. Huh? All surfaces are smooth. What happens to block? If I release the block will slide down. Am I right? Slide down with what acceleration? Do you remember? Very good, Sailila. Sailila will answer. What about others? If I release the block on the inclined plane, what happens to the block? Block will come down with what acceleration? If I release the object will come down. What is the acceleration with which it will come down? With what acceleration it will come down? With an acceleration of g sine theta. So many people forgot. Very less people remembered it, right? Most of the people are not dedicatedly reading the notebook. Notebook reading is not happening. I can easily smell it. Okay. ఎందుకంటే see, I told this one. మంచిగా డిస్కస్ చేస్తాం మనం. Inclined plane మీద బ్లాక్ పెడితే g sin theta acceleration కిందకి రావాలి. The time taking will be inversely proportional to theta. If inclined plane inclination is more, it will take less time. If inclined plane inclination is less, it will take more time. That also we discussed. If you are forgetting, then what is the use of discussing all these things? See, if you are not reading the notebook, then you are not at all will be in the game. Okay, remember that. Okay, this is the case when inclined plane is fixed. But what is our scenario? Our scenario is something different. Now I'm taking inclined plane which can move. Now inclined plane is movable. What is the meaning of inclined plane is movable? We can move the inclined plane. Suppose if I keep the object of mass m, then this block has to slide on the inclined plane. Am I right? If I keep the block has to slide down. Inclined plane will block it on the kinda ground because all surfaces are smooth. Block kinda ground. But మన inclined plane ni accelerate చేసాం అనుకోండి. Suppose I have given acceleration to the inclined plane. Now by moving the inclined plane forward, then block will stay at rest on the inclined plane. Inclined plane మీద బ్లాక్ మూవ్ కాదు. ఓకేనా? So what we have to find out, find the acceleration of inclined plane. Find the acceleration of inclined plane. Okay, so that block stay at rest on the inclined plane. So ఎలా ఉండాలి? అది కింద పడకుండా inclined plane మీద రెస్ట్ లో ఉండాలి. inclined plane మీద స్లైడ్ అవ్వకుండా అక్కడే రెస్ట్ లో ఉండాలి. అలా ఉండాలంటే ఎంత యాక్సిలరేషన్ ఇవ్వాలి మనం? inclined plane కి ఎంత యాక్సిలరేషన్ ఇవ్వాలి? That is the question. What should be the acceleration given to the inclined plane so that block will be at rest on the inclined plane, or block will stay at rest on the inclined plane? You understood the question? You understood the difference between left side diagram and right side diagram? Left side diagram lo inclined plane emo fixed ga undi. Right side diagram lo inclined plane emo move avutundi. Okay. Carefully observe the question and solve it. బ్లాక్ ఎలా ఉండాలి? inclined plane మీద రెస్ట్ లో ఉండాలి. మీరు బస్ మూవ్ అవుతుంది అనుకున్నాం. బస్సులో మీరు కూర్చుంటే బస్సులో మీరు రెస్ట్ లో ఉంటారు, కానీ గ్రౌండ్ నుంచి చూస్తే మీరు బస్తో పాటు మూవ్ అవుతూ ఉంటారు. ఓకేనా? సో కేర్ఫుల్లీ హౌ టు ఇమాజిన్ ద సిచ్యువేషన్ ని ఇమాజిన్ చేసుకోవాలి కేర్ఫుల్గా. ఓకే, any answer? Parallel saying G cos G sin. Parallel, what is the answer for this question? You are saying G cos, huh? Okay. So verify చేసుకున్నాను ఆన్సర్. Verify your answer again. Any other answer? Any other one got? Invite any answer? Glory Navia. Number. See here also observer is not given, right? We didn't take any observer. To solve the question, first of all, you have to decide where is your observer. So I'm taking now see. Now inclined plane is moving with what acceleration? A acceleration. Now block is staying at rest on the inclined plane. What does it mean? Then block is not moving on the inclined plane. On the inclined plane, block is not moving. But if you see from the ground, inclined plane is moving, then block also will move along with the inclined plane. If you see from the ground, block also will move along the inclined plane. Block will move along the horizontal. For example, best example is you are there in the bus. You are just sitting in the bus. That means you are at rest inside the bus. If bus is moving, then you will be moving with respect to ground. But inside the bus, you will be at rest. If anybody observes you from inside the bus, then you will be seen at rest. Bus lo మీరు కూర్చున్నారు వేరే వాళ్ళు చూస్తే మీరు ఎలా కనిపిస్తారు బస్లో ఉన్న వాళ్ళు చూస్తే ఎలా కనిపిస్తావు నువ్వు రెస్ట్ లోనే కనిపిస్తావు అదే గ్రౌండ్ లో ఉన్న వాళ్ళు చూస్తే నువ్వు బస్తో పాటు మూవ్ అవుతున్నట్టు కనిపిస్తావు సేమ్ లాజిక్ హియర్ ఇన్క్లైన్ ప్లేన్ ప్లేస్ లో బస్ తీసుకోండి పర్సన్ ప్లేస్ లో ఆబ్జెక్ట్ తీసుకోండి సో వేర్ ఈస్ ద బెస్ట్ ఐ మీన్ who is the best observer? Observer from the ground or observer on the inclined plane? Where to take the observer? From where it is easy to observe the things? From where we need to observe the situation? Station, if you see from the ground, then block will accelerate forward. If you see from the ground, then block will accelerate forward. Inclined plane move అవుతుంది కాబట్టి block కూడా move అవుతుంది. Inclined plane accelerate అవుతుంది కాబట్టి block కూడా accelerate అవుతుంది. ఓకేనా తెలియని? So that is, I mean, little imaginary things. If you can imagine, it will be easy. But what is the best way is take the observer on the inclined plane. If you take the observer on the inclined plane, how the block will appear to him? To him, it will appear at rest because block is not moving on the inclined plane. Block is not moving on the inclined plane. So if you observe from the inclined plane, block does not move. And then see what are the forces acting on the block. Mg will act downward. Normal action will act perpendicular to the inclined plane. These two things we have done already. In the inclined plane case, I explained. Now, observer is inertial observer or non-inertial observer? He is non-inertial observer. Okay, no? The observer is non-inertial observer. So we have to apply the pseudo force also. How the pseudo force will act? Pseudo force will act MNTA in backward direction. Pseudo force MNTA will act in backward direction. Then three forces are there: Mg, Me, and normal action. We have to find out the what is it? A value. Me value how to find out automatically. Okay, no? So what is the best way to do this? If I'm extending this line, what this angle will be? Theta. Already I told sine component will be down the inclined plane. Cos component will be perpendicular to inclined plane for Mg. Mg sin theta always act down the inclined plane. Mg cos theta will act perpendicular to inclined. If this angle is theta, this angle also will be theta. Now you can make into components of Me also. Me is making angle theta with the horizontal inclined plane. So Me cos theta component, and what the other component is? Me sin theta component. Me cos theta and Me sin theta. Then on the block, what are the forces acting? If you want, you can draw them again. On the block, Mg sin theta is acting downward. Me cos theta is acting upward. Normal action is acting perpendicular to the incline. And this is Me sin theta. And this is Mg cos theta. Okay, no? Object is at rest. Object is at rest means all forces should cancel out. These two forces and these forces will cancel out. Down the inclined plane will cancel out with up the inclined plane. And what the normal action value is equal to? Mg cos theta plus Me sin theta. Okay, no? So then I can write down M value will cancel out. Then what the A value is equal to? G sin theta by cos theta, which is equal to acceleration value is equal to G tan theta. So what the acceleration of inclined plane required? The acceleration of the inclined plane required is G tan theta, so that the block will be at rest on the inclined plane. All of you understood? So same question you can solve from the ground frame also. But if you are solving from the ground frame or observer on the ground, you should not apply the pseudo force. And block won't be at rest. Block is accelerating forward because inclined plane is accelerating forward. Okay, understood? Okay, what's the content video? See, all of you revise the notes. I can feel that you people are not revising the notes well. The notebook లో ఉన్నవన్నీ ప్రతిదీ చూడకుండా రాయాలి అప్పుడే మీకు గుర్తుంటుంది. If you are unable to remember the things, then you will be in great trouble in solving the physics. No doubt. Okay, so దాన్ని ఎవరు ఎస్కేప్ చేయలేరు. ఈవెన్ నేను కూడా చదువుకునేటప్పుడు ఎస్కేప్ చేయలేదు. నేను కూడా చదువుకున్నప్పుడు ఫిజిక్స్ మళ్ళీ ప్రాక్టీస్ చేసినాను. ప్రాక్టీస్ చేస్తేనే ఇవన్నీ వచ్చాయి, లేకపోతే వచ్చిండేవి కాదు. నాట్ ఓన్లీ ఫిజిక్స్, ఈవెన్ కెమిస్ట్రీ ఆల్సో, ఈవెన్ బయాలజీ ఆల్సో యూ హావ్ టు ప్రాక్టీస్. కాకపోతే ఏంటంటే అక్కడ మీరు ఎక్కువ చదవాల్సి ఉంటుంది కాబట్టి మీకు దెర్ ఈస్ ఎ డిఫరెన్స్ బిట్వీన్ ఫిజిక్స్ కెమిస్ట్రీ అండ్ బయాలజీ అండ్ బయాలజీ పార్ట్. అక్కడ కూడా లాజికల్గా ఉంటాయి క్వశ్చన్స్, కొన్ని క్వశ్చన్ లాజికల్ ఉంటాయి. సో దట్ యూ హ్యావ్ టు థింక్ మోర్, యూ హ్యావ్ టు కనెక్ట్ ద థింగ్స్ వెల్. Okay, wrote down. All of you try from the ground frame. If you don't get, let me know. Tomorrow I'll explain that. On the ground frame, solve guidance. Same question, you have to try from the ground frame also. Okay. Okay, I have to finish that. Still writing? Anyone writing? Let me know. Okay. Completed. So all of you revise this. Okay. మళ్ళీ మీ అందరూ చూడకుండా రాయడం ట్రై చేయండి. చూడకుండా రాస్తేనే మీకు వస్తుంది, లేదంటే రాదు. ఏదో రివైజ్ చేయమంటే పేపర్ ఇచ్చే ఫిజిక్స్ వస్తే ఇంక అందరికి ఫిజిక్స్ వచ్చేస్తుంది. అండ్ ఫిజిక్స్ ఇస్ నాట్ ఎ టఫ్ సబ్జెక్ట్, ఫిజిక్స్ ఇస్ ఈజీ సబ్జెక్ట్. మీరు పేపర్లు తిప్పి రివిజన్ చేద్దాం అనుకుంటే మాత్రం ఫర్గెట్ అబౌట్ ద ఫిజిక్స్. రివిజన్ చేయాలి, చదవాలి, మళ్ళీ రాయాలి. అప్పుడు మీకు అర్థం అవుతుంది మీరు ఎక్కడ మిస్ అవుతున్నారు అనేది. That we can discuss. Okay? Yeah. So bye everyone. Meet tomorrow.